So this is the answers to questions from section 10.3. I can tell you that this one actually, I promise, is going to go very quickly. Make sure you're paying attention here because this is a very similar type of thing to the test of homogeneity. The main difference between this test and the previous test is when you use this one versus when you use the other one. The way they are performed, the way they are put into the calculator is identical. So the big difference is that in order to use a test of independence, you have to select one single random sample from a large population, rather than multiple fixed random samples. So if I read number 35, it says a student surveyed a random sample, notice singular, of 300 students in her large college and collected the data on 2 variables. So that right there tells me that that is meeting the condition for the chi-squared test of independence. One large random sample classifying by 2 variables. So if I come down here, I can see that those 2 variables were what class they were in and their favorite team sport. So they would like me to perform a chi-squared test to determine if the class is independent of their favorite team. Now, you think in your mind, should being in the freshman, sophomore, junior, or senior class affect what your favorite team sport is? You wouldn't think so. So right off the bat, you're thinking that these are probably independent results. But statistically speaking, maybe there is something about these college students that causes them to like a certain sport more than the others when they are seniors versus juniors, sophomores, or freshmen, something along those lines. So I am going to go ahead and run the chi-squared test of independence. So on my calculator, and I just realized that I practiced this beforehand, I have the results, so pretend you didn't see those. I'm going to hit second, and I'm going to hit inverse, and I'm going to go over to edit, and I'm going to change matrix A. Now, I already have all the data inserted. You likely will not. The results are only going to include the values, not the totals. So we only want to see the values that were obtained. We don't need to include the totals. That's why this is a 4x4 and not a 5x5. So I have inserted all the data. There were 4 classes, so you'll notice that there are 4 rows, and there were 4 options for favorite team sport, and that's why there are 4 columns. Keep in mind that you could move these numbers around into any of the rows or any of the columns you wanted. You could completely flip-flop the rows and columns if you wish. None of that matters as long as the numbers that are in row 1 are somewhere in one of your rows or one of your columns. So realistically, you can move these numbers around quite a bit. That doesn't matter. Now, are these basically things that have no overlap? Well, they did say favorite team sport. They didn't say one of your favorite sports or do you enjoy this sport? It said favorite. So we assume that people only chose one. They shouldn't overlap in terms of their class. You can't have somebody that's simultaneously a freshman and a sophomore. So we know that everything should fall into one category. Now, we have a large random sample. We have everything falling into one category. The last thing we need to check is, are the expected values all going to be at least 5? Now, I don't want to do that by hand. So if I run the test, and you'll notice that I already did that, you kind of saw a sneak peek of that when I went to this screen. If I run the test, stat, test, and then I scroll down to chi-square test. On my calculator, it's option C. I don't have to actually put anything in the expected matrix. I can literally just tell it where to put the answers. So I have chosen matrix B, and then I went and I calculated. When I did that, not only did it give me the result of the test, but if I went back to the matrix, it has created the expected value matrix for me. So after I would have hit calculate there, guys, it will create this matrix. I did not insert these numbers. The calculator did this for me. So now I can check to see if they are all at least 5, and the only one that really came close was the top right corner. But even that one is 5 or more. So all the conditions for a chi-squared test of independence have been met. One large random sample, no overlapping variables, and all the expected frequencies are at least 5. So what is my null hypothesis going to be? Well, thankfully for you guys, this is the easiest one to write the hypotheses for, by a mile. So the null hypothesis is always going to be one variable is independent of the other. So in this case, the class is independent of their favorite team sport. And the alternative hypothesis is that class is not independent of their favorite team sport. It doesn't get much easier than that. Null hypothesis, they are independent. Alternative hypothesis, they are not independent. Quite simple. So now I go over to the test. And this will likely be the second time that many of you are running this. This calculator doesn't like to save things that are on the home screen, so that's why I have to run it again. But if you ran it to check the expected matrix, you might be able to go back to your home screen and your results will still be there. And you can see I got a test statistic of 10.596 and a p-value of 0.3044. Now keep in mind, if this was a z-test statistic, 10 would be huge, but on a chi-squared with 9 degrees of freedom, this actually is not a huge test statistic at all. The p-value of 0.3044 is considered quite large, which means that the result is not statistically significant. We do not reject the null hypothesis, and that means that the two variables are independent, or at the very least, we have evidence to support that the two variables are independent of each other. Okay? So had we gotten a very small result, that would make it statistically significant. We'd reject the null hypothesis, and we would say that there is evidence to support that the two variables are in fact not independent of each other or dependent of each other. So it is one of those things where we are testing to see if it is or is not that the evidence supports those things. Evidence on this one supports that the two variables are independent, which is kind of what we expected. All right, so that's it. That's all there is to this. This is pretty simple. Let's take a look at the other parts of the question. Could you have made a type 1 error? Remember that a type 1 error is rejecting something that was false. We got a p-value that was relatively large, which means our result was we do not reject the null hypothesis. So no, it was impossible for us to have made a type 1 error. However, because we did not reject, we could have made a type 2 error. If somehow the two variables are in fact not independent and we got our result, well, that would mean we've made a type 2 error. We failed to reject something that was supposed to be false. Part C, describe how the survey should have been designed in order to test for homogeneous proportions among the populations of freshmen, sophomore, juniors, and seniors. This would not have taken much extra work. All they would have had to have done is, instead of taking 300 random students, they would have had to have gone out and got a fixed random sample from each of the classes. So if they think that all the classes have equal representation at this college, they should simply go out there and get approximately 75 students from each grade. 75 freshmen, 75 sophomores, 75 juniors, 75 seniors. If they believe that one of the classes is more represented than the others, you should technically pick something proportional. So it would be one of those, if the freshmen are larger than the other three groups, then maybe you get a fixed sample of, 80 freshmen, and then you only get samples of 70 sophomores, 70 juniors, 70 seniors, maybe something like that. And, that would be a good way of doing it. But it doesn't matter how many you choose. They don't have to be equal. You're just trying to pick fixed random samples from each group. And then you would just test to see if the distribution of favorite sports is the same for each of the grades or classes. So a very minor tweak, and this could have been a test of homogeneity. You'd still end up with the exact same result if you picked those sample sizes over to the right. Obviously, I don't know why anybody would pick a fixed sample of 63, 80, 74, and 83 unless they knew that those were the exact proportion of students on campus. But, more than likely it's probably going to be nicer rounded off numbers if you're going to do that kind of thing. All right, guys, so that means for number 37, I'm not going to walk through this one. I'm going to simply show you the results. Instead of having a 4x4 matrix, you should have had a 2x2 matrix. Your goal was to determine if gender and survival status of the actual people on the Titanic was independent. Now, I don't know about you, but it doesn't really take a rocket scientist to look at those numbers and see, wow, a lot of the males died. And then you look at the females and you're like, man, a lot of the females survived. It certainly looks like gender did in fact play some role in their ability to survive on the Titanic. When there's 4 times as many males as there are females on the actual ship, but almost the exact same physical number of them survive, and that tells you there's probably something to be said here. So, you'd plug these numbers into a 2x2 matrix. You would check to see if the expected values were all at least 5. They are. This is certainly not a random sample, but you'll notice in the question it says, this data cannot reasonably be considered a random sample from any well-defined population. Well, that's okay. We're only trying to see if these 2 variables are independent of each other on the Titanic. I'm really not trying to generalize this to all large cruise ships that happen to crash into icebergs. That would be a very weird thing for me to gather data on. So this is very specific to this ship, and that's just fine. So I'm not worried about the fact that it wasn't a random sample. Everybody should fall into one category, we would think. I don't know how you simultaneously survive and don't survive from it, but maybe. I guess there's the possibility. And so now we just have to run the test, and I will once again just show you the results. So you should end up with a test statistic of, wow, that's a big number, 456.9, giving you a p-value of, notice what my book says, 0. So obviously the scientific notation on this would have had a very, very large negative scientific notation. So times 10 to the negative something very big. So that means that we will in fact reject the null hypothesis, and we have pretty clear evidence to support that the 2 variables are not independent. Because your null hypothesis would have been that gender and survival status are independent of each other on the Titanic, and your alternative hypothesis would have been that gender and survival status are not independent of each other on the Titanic. And it's pretty clear on this one, since we are rejecting the null hypothesis, evidence definitely supports that those 2 variables are not independent. So pretty simple. Fun fact, I just wanted to show you A. A said, make a graph displaying the results here. And if you remember what I told you back in the lesson, they really are big fans of these column charts. So here's them literally showing you what they expected you to try to display. So I think without a piece of technology, that is laughable. If any of you are artistic and took the ability to make one of these, well, very nice. That's what it would look like. Isn't that pretty? So yeah, so if you skipped part A, I'm not blaming you. As long as you could answer part B, that's what's important to me. All right, guys? So before I wrap things up here, just a couple of things to mention. On Tuesday, not Thursday, on Tuesday, I will be emailing you the quiz that's going to cover sections 2 and 3 of Chapter 10. You are not receiving a quiz for week 3 and a quiz for week 4. You're going to get one larger quiz that's going to cover both weeks. You'll then receive a score, and I will give you that score twice in Progress Book. So please keep that in mind. Also, I was trying to debate on whether, for the last 2 weeks, we would start Chapter 11 or if we would do a review. And I have decided to go the route of a review. So week 5 is going to be reviewing testing. We're going to look at a review of proportional testing, which was Chapter 8, testing of a mean, which was Chapter 9, and chi-squared testing, which is this chapter. So you'll have a review of questions to work on for week 5. And then for week 6, there will be no lesson. It will just be a quiz that is given to you. So for the final week, for week 6, I am just going to email out a quiz on Sunday, and that one will be due on Friday, so before Saturday, midnight Friday, because technically speaking, the last day of school is May 15th. So I just want to give you guys that heads up going forward. So after you take this quiz next week, for week 5, it'll be review questions, and then for week 6, it will be a quiz and a quiz only. So that's what to expect going forward, guys. Hopefully this has been helpful. I will talk to you guys in the review question video next week, or maybe even the week after, depending on how long you put it off. But regardless, if you guys have questions, continue to email me, and I will talk to you guys in the next video.